There are two special applications of percents that I want to take a look at specifically. One of them is percent increase or decrease. When we see the phrase percent increase or percent decrease, we're interested in the change compared to the original value. And that original value, that's going to be what represents the whole. So here's what that looks like. We could say the price of a sofa was $179. But now it is $299. We want to know what is the percent increase. And as soon as I see that phrase percent increase, that needs to cue me in that we're looking at the change compared to the original. What is the change? Well, the change is going to be the change in price. It's now $299. It was $179. If I subtract those, I see the change in price has been $120. We're going to compare that change to the original value. The original value, the price of the sofa, was $179. That is my whole. So I've got my part, which is 120, over my whole, which is 179. That's equal to my percent, that's what we're looking for, over 100. Multiplying both sides by 179 times 100 will allow me to start solving. That's going to give me 12,000 equals 179x. And when I divide both sides by 179, I get, I'll put my answer over here, a 67.04% increase. So with percent increase or decrease, we compare the change to the original, where the original value is the whole. Let's do one more. Let's say the temperature of the lake was 39 degrees. Now it is 34 degrees. What is the percent decrease? Again, we see that keyword percent decrease. That should cue my brain to ask, what is the change? How much has the temperature changed? It was 39. Now it's 34. It's changed by 5 degrees. We're going to compare that change of 5 degrees to the original value. The original value of the lake, it was 39 degrees. That is my whole. So I'll set up my part over the whole. The 5 over the 39 is equal to the percent I'm looking for out of 100. And then I can solve this proportion like always, 39 times 100, multiplying by the denominators so that I can reduce those numerators out, giving me 500 equals 39x. And finally, dividing both sides by 39 to get my x, my percent decrease this time, of 12.82% decrease in the temperature of the lake. The second special application of percents I want to look at is simple interest, where you put money in the bank and you earn simple interest. The bank pays you money to leave that money in the bank, and so your money grows by that amount of interest. The special thing to know with simple interest is it matters how many years the money is in the bank. You get that interest percentage every year. we are going to multiply the interest rate, or the percent, by the number of years. That's the special thing when you see the word simple interest. So if a bank pays 2.1% simple interest, and you invest $3,500 for 4 years, how much do you have? Your investment of $3,500 represents the total amount you've put in. $3,500 is the whole. What we want to know is how much we have. So we'll take the part we don't know, that interest you've earned, out of the whole, which is $3,500, equals the percent, 2.1, out of 100. But remember, with simple interest, we have to multiply that interest of 2.1% by the 4 years, by the number of years. That's the special thing with simple interest, because you earn that percentage every year. Now to solve, we'll multiply both sides by 3,500 and the 100 so that they can divide out, leaving behind 100x is equal to 2.1 times 4 times 3,500. I get 29,400. And so we can divide both sides by 100, and x is equal to 294. But just like our previous video, be careful that $294 is what goes with the percentage. That's the interest that you have earned. So you didn't lose money. You didn't go from 3,500 down to 294. No, you started with 3,500 and you earned an additional $294 in interest. That means you now have $3,794 in the account. Let's do one more simple interest problem. Let's say a bank gives a $12,000 loan with 4.5% simple interest for 9 months. How much is owed? Very similar to the previous problem. That $1,200 loan represents all of the loan. That is the whole. We're looking for that part, the interest that was charged. So we put the part over the whole. X over 12,000 is equal to the percent, which is 4.5% over 100. But because we have simple interest, we have to multiply by the number of years. Except this has 9 months. Well, how many months in a year? There's 12 months in a year. So this represents 9/12 of a year. And 9/12 actually reduces down to 3/4 of a year. So I need to multiply that interest rate by 3/4 because it's 3/4 of a year. Simple interest is per year. Multiply the interest by the year. Now we can multiply both sides by 12,000 times 100. 12,000 times 100. So the 12,000 and the 100 reduce out, and I get 100x is equal to 4.5 times 3/4 times 12,000, and I'm getting 40,500. So to solve for x, our interest by dividing by 100, x is equal to 405. But again, be careful, that percentage is talking about the interest. That means I earned $405 in interest. The loan was $12,000. we have to pay an additional $405 in interest. And so the total amount owed is $12,405. So as you're doing your applications of percentages, be careful of the key phrases of percent increase or decrease and simple interest so you can make these minor adjustments to arrive at our correct answer. It's your turn to practice these. Let your instructor know if you have any questions.